This section is Enterprise Network Constructs and introduces the physical components and technologies found within an enterprise network. Establishment of an enterprise network requires a fundamental understanding of general networking concepts. These concepts include knowledge of what defines a network, as well as the general standards of technology and physical components that are used to establish enterprise networks. An understanding of the underlying network communications and the impact that such behavior has on the network is also paramount to ensuring performance-effective implementation. So upon completion of this section, it is expected that trainees will be able to explain what constitutes a network, identify the basic components of a network, and describe the primary mechanism for communication over the network. As we have previously mentioned then, networks represent the basis for communication. And in order then to establish a network, it is necessary that we have two or more entities that are able to communicate or are communicating over a common medium. So we can see an example here of certain end stations which represent those entities. And these can represent many different forms. So for example, these may be host stations, servers, wireless access points, or even printers. And also together with this, we require a form of physical medium. Now this can also represent many forms, for example, electrical cables, optical cabling, or even wireless radio frequency, which may actually be used to carry signals. So in all cases, however, we should understand that the principles for communication, however, are the same. Coaxial represents one of a number of media types, and possibly one of the older media types that are capable of supporting Ethernet networks. It is basically a single copper wire that is able to provide point-to-point communication or be shared by multiple hosts. There are two standards, as we can see here, in the form of the 10-base-2 and 10-base-5, in which this format represents the capability of the medium. So 10 represents the maximum transmission rate that is supported. Base refers to this being a medium for supporting baseband technology, and the 2 or 5, an approximation of the transmission range supported. So we can see here that the 10-base-2 represents a transmission distance of approximately 185 meters, while 10-base-5 represents a distance of around 500 meters before attenuation causes signal degradation. Connector types include the BNC connector for 10-base-2, and we can see an example of that here, as well as the N-type connector that is used for 10-base-5. So with transmission capability of 10 megabits per second, its use, however, in today's networks is generally limited. Ethernet represents the most common form of medium supporting Ethernet networks today, and is comprised of pairs of wires over which electrical signals are transmitted. This provides an advantage over coaxial medium types, since the electrical signals can be isolated over separate wires. So different categories of Ethernet medium exist and represent an increasing capability to support higher transmission rates. So examples include the 10-base-T, which involves communication over a 2-wire pair of twisted cables. The 100-base-TX represents a category 5 type cable that supports a higher transmission rate, and the 1000-base-T or category 5 extended medium that uses 4-wire pairs for supporting gigabit Ethernet transmission rates, which is in the range of around 1000 megabits per second. The RJ45 connector that we can see here represents the common connector type that is used for Ethernet media. Fiber optic is an increasingly popular media type that uses optical signals to carry transmissions communicated between two endpoints. Optical signals have a lower rate of degradation than is found with the electrical signals in other media types. And so the optical medium is able to support transmission over much greater distances before attenuation becomes an issue. It also does not suffer from electrical interference from external sources, as is found with other electrical media types. Another reason for the growing popularity of fiber optic medium is due to its capability to support gigabit Ethernet transmission rates of 10 or even as much as 100 gigabits per second, with the potential for even greater rates. So two modes are used to support optical transmissions in the form of the single mode and multi-mode. A single mode fiber will only support a single optical signal for which transmission distances can reach tens of kilometers. Multi-mode involves transmission of multiple optical signals over the optical fiber and can be generally understood to have a much shorter transmission range. A number of different connector types also exist. However, common standard types include the ST, SC, and LC connector types. Serial is a legacy media type that supports other forms of non-Ethernet based communication, but is still used in many forms of network alongside Ethernet as part of the enterprise network. So while network technologies are slowly being phased out in favor of Ethernet, many non-Ethernet technologies continue to be applied or supported, for which serial cables represent the communications medium. Transmission rates are considered to be pretty low based on today's standards, and distance of transmissions are also not as competitive as they used to be. However, technologies that are dependent on a serial medium will be introduced in the intermediary part of this course, and therefore a familiarity with the serial media type and how communication differs from that of Ethernet will be developed through the course of the training, to strengthen the skills for maintaining and resolving communication issues over serial connections. So a couple of examples as we show here with serial types that are supported include the RS-232, RS-422, as well as what is not shown here, the RS-485 standard. So these standards are gradually being replaced by new serial technologies, such as the Universal Serial Bus or USB standard, in order to support short-range communications, and is used today commonly in place of the popular RS-232 standard. Any form of communication requires conformity to certain rules or patterns which can be understood and interpreted by the receiver. Transmission of signals that carry the data may take on various forms, such as in the case of Ethernet or serial and electrical current, for fiber optic, light, and where we are using wireless connections we have frequency waves. And each form of signal consists of different properties and behavior. Ultimately, however, it is necessary that the communication between the sender and the receiver is synchronized, and transmissions sent by the sender can be understood and interpreted by the receiver. Signals over Ethernet are defined by voltage to represent two states of 1 and 0 that can be interpreted by the receiver based on patterns in the transmission. Together with the fixed rules for synchronization, known as line encoding, sending and receiving entities are capable of handling data communications over the transmission medium. So different rates of transmission require the use of different line encoding standards to synchronize clocking and ultimately ensure the transmission can be successfully interpreted once the signals are received. Early enterprise networks supported communications over coaxial cables that represent a form of shared medium over which two or more end stations attempt to communicate. Problems arise, however, when multiple end stations attempt to transmit data over the shared medium at the same time. The electrical current effectively flows over the network to all destinations, but not before colliding with the data signal of the neighboring end station. This collision results in a distortion of the data, which cannot be interpreted by recipients, and so the transmission is lost. Such environments where transmissions flow between neighboring stations is referred to as a collision domain. So in the case of communication over a shared medium, such as 10^2 or 10^5, it is necessary for a process of testing as to whether the medium is clear before transmission can occur. This is similar to looking both ways before crossing a road, using a process that is now known as the Carrier Sense Multiple Access Collision Detection, or CSMA-CD. But even then, collisions may still occur. Different media is capable of supporting different modes of communication, modes that are represented as either half duplex or full duplex. Where we have a shared medium, such as in the case of coaxial, it is only possible to support communication in one direction at any given time. Simultaneous communication in both directions would result in continual collisions occurring and failed transmissions, and so communication over a shared medium should operate in a half duplex mode. In the case of Ethernet, twisted pairs of wires supply dedicated communication over the separate wire pairs and effectively ensures collisions cannot occur over the medium. Hub devices introduced into an Ethernet network do, however, represent a point at which collisions can occur, and so such networks may operate in either full duplex mode or half duplex mode where hubs are used. In summary of the topics covered then, we ask here, which forms of cabling can be used to support gigabit Ethernet transmissions within an enterprise network? Well, Ethernet twisted pair cables of Cat5e and greater, as well as fiber optic cables that support the 1000 base standard or higher, can be used to support the transmission rates within the gigabit range. What is a collision domain? Well, a collision domain is a physical segment of the network within which signals that carry data are transmitted. Shared collision domains have the potential to experience collisions as a result of simultaneous transmission by two end stations attached to the same medium. Isolated collision domains ensure collisions do not occur by dedicating the signal transmission to different physical segments, as is found typically in twisted pair cabling such as Ethernet Cat5 and Cat5e. What is the purpose of CSMA CD? Well, the carrier sense multiple access collision detection is used to reduce the chances of collisions in a shared collision domain. This occurs prior to transmission, during which the end station will effectively listen for transmissions. If all seems quiet, transmission will proceed. However, should a collision still occur on the link, host will cease to transmit for a short but random period of time before reattempting transmission.